Hello, welcome to CPO 240 Quality. This is session 14 on process capability. So this is the last session that actually has you work with the QI macros. Okay, I put them all together so that if you wanted to do that 30-day trial, it wouldn't mesh up. Okay, so we're going to talk about process capability. So what we're going to do today is learn about process capability. We're going to discuss the limits of it. We're going to discuss what CP means, CPL, CPU, and then what the CPK indices all mean. We're going to compare and contrast potential capability with actual, and then we'll explain the benefits of these. Okay, standardization versus improvement. So bringing a process into control is not process improvement, it's standardization. So once it's standardized, then you can improve upon it because then you know what you're doing, you're working through it. So process capability is the measured inherent reproducibility of the product turned out by the process. Here, and this is really what it means, the ability of the process to produce what it is intended to produce over and over again. So CP means whether or not a process can meet its product's specifications and how effectively it meets them. So if we look at this process capability here, we see this graph, and it's showing the intervals of plus and minus 3 sigma. So we've talked about what a sigma means, and it takes you within this total of the plus and minus sigma is this 6 sigma, which you might have heard before. The 6 sigma is the tougher qualifications to meet. But anyway, it takes you to 99.73% of your measurements will be within this interval. And the specifications will be limited as your upper limit and your lower limit. But can shows the relationship between the process's inherent fluctuations versus what the customer's tolerances are really going to be about. Okay. So let's talk a little bit about control limits and specification limits. So it's the voice of the process and calculated data, but specifications come from the customer. These are appearing on the control chart and they apply to the subgroups. These are on those histograms, and we'll see them again. The histograms this process capability charts look very similar to histograms. These apply to items. Now there's a guide for process actions on the control limits and it shows you what the process is doing. When we did those when we did the control charts, we could see whether or not it was falling within those bounds. This separates the good items from the bad and what we want the process to do. Okay. All right, so if we look at this again, this shows you minus 3 sigma and plus 3 sigma gives you a total of the 6 sigma. And these limits here are generally within the engineering specifications. Let's go to the next slide. All right, to do a capability study, you must know whether or not the machine or the process measured parameter of interest is normally distributed. So that's what you need to find out here. So here you can see that it is normal. This is a normal probability plot here, okay? So this is your histogram and then the probability plot, all right? That shows it. Let's look at these. Here you see it's skewed to the right. Well, it says left skewed, sorry. Over here it's skewed as a right skewed distribution. So again, they're not looking on target. Okay, we're not seeing that nice bell-shaped curve here. A right skewed distribution. So there's your histogram, and then you can see your normality plot. Here you have a bunch of data, right? All of this is that data collected right here, and then it distributes itself over there. Okay, so process capability index. So remember, a process consists of people, materials, and machines. So when we look at the index, this is what we want to look at. How capable is the stable process of meeting the requirements or the specifications? So the PCR is a ratio which compares the capability to the process, of the process to the customer specs. So the top number is the engineering requirements, and underneath that is the statistical requirements. This is where engineering requirements are in terms of the upper limit and the lower limit, okay? And the statistical requirements are in standard deviations, okay? So we're going to talk about these right now, CP, and then the CPL, CPU, and the CPK. All right, so CP is the index of potential capability. So this is the critical part that you must understand. A process or product with the CP greater than or equal to 1 means that it has the potential, okay, to meet the customer specification. They expect them to be greater than 1.5. And then a CP less than 1 shows you there's some type of problem going on, and that has to be corrected. This comparison does not take into account where the process is centered. So you could have a CP of a good number, but you have to make sure it's not skewed and sliding to one side or to the left or to the right, as we talked about. So that skewed proportion. Having a capable process does not necessarily mean that the products are in the specification limits. Okay, so here's we're going to look at these now. So if you look at this here, these are in your book on page 247. So this one here, A, is the upper and lower specification limits are far beyond the plus or minus 3 standard. Okay, you can see that here from the average. Obviously, the CP is greater than 1 because the figure shows that more than 99.7% of the data is falling within the requirement, so you can see that. Now B, in this case, which almost never happens, the plus and minus 3 sigma are almost exactly within the specifications, and that gives you exactly a CP of 1, okay? That is kind of hard to do. Now, you have to watch this process because it may just slide one way or the other, and it's giving you the specifications you need right now, but it's very close to meeting the limit, being close to either end of going off. C, in this particular instance, are inside the plus or minus 3 standard deviations from the average. That means there are some off-spec materials resulting on both ends of the distribution, and drastic process improvements probably need to be made. This is probably less than 1 CP. And then over here, okay, we're looking at D. This is off-center, okay? So it's kind of hard to tell, but you can see here, this falls on the negative side, the lower end, but the upper end is not even close. This positive 3 sigma is not even close to the upper end. So that's what they mean by that. So the specification is not being met on the low side, okay? And this process would also have a CP of less than 1, all right? So that's just important to understand. So you could have the CPs where you need, but we just have to look and be careful and see how they fall. All right, now there's a capability exercise number 1. It's the forged piston ring process. So if you go into your D2L, you'll see under there exercise 1. And in that Excel book are 3 tabs. There's the forged piston ring and then the other 2 tabs, and we're going to get to them, okay? So you're going to run the data. I want you to run it, okay? And then you're going to get this information. This is what it looks like. So here's the normality plot. It looks pretty good, doesn't it? All the points. There's a little bit over here on this end. So let's see what it looks like. Okay, we have a pretty decent shape here. So let's see what our CP is. Our CP is 1.66. That's pretty good. The CPK is 1.54. And then we have these other ones here, and we're going to talk about each of them. The CPU and the CPL and the CPM. I'm not sure if we talk about the M. Okay. CPL, it means the index of the actual performance on the lower specification limit. All right, so the CPL over here is 1.78, okay, which is really high, which means, right, we only have this little bit stepping out on the low end, okay? If you look at the CPU, it's 1.54. We have a lot more closer to the upper spec limit. It's still within the limits of a good CPK, a CP, I mean. So here again, you're looking at the upper spec limits, okay? So that's what they mean. So again, here you have different examples of them, all right? The CPU, the upper limit is 0.67, okay? So you see that much is out of spec. Here it's 1, it's perfect, all the upper limits are good. 1.33 means it's even better. And then 2 means they're just really looking good. You're not getting anything, you're getting everything really, really finely made well with hardly any deviations on the high end. Okay, that's how that means. Now the CPK means the index of the actual performance. So that is determined as the minimum of the CPL or the CPU, which of those two, okay? And it takes into account where the process is centered. So it just takes the minimum of these two. That's all that is, okay? So let's look at the next one. So CPK over here is the distance over the spread. So it's the measure of the process spread, okay, on the low end here and then the upper end. And it's the distance of the process average from the specification. So again, it's just another number that's generated. And again, it's really great because QI macros do all this for you. Okay, why CPK versus just the CP? So all these examples here have a really good CP. They all have the same CP, but they're not all capable processes and capable of producing on-spec products. CPK takes into account whether or not it is centered within the spec limits. So that's what's important to know, the difference between those two. Okay? Now, there's a process capability exercise 2. Again, in that same Excel spreadsheet, the next tab will be bottle bursting, and they want you to determine the CPK with that data. Again, I want to show you what it looks like. So here, this is a probability plot. It looks pretty good, doesn't it? Look at this, though. This is a beautiful picture here. The CPK is 0.67, so that looks really good, doesn't it? But it's actually telling me that it's not really that great. And it is off-center here, so you can see that it's skewed a little bit more towards the upper limit the upper specification limit. And then a bunch of these are a little bit out of range right here, out of this whole bell-shaped curve. So, and the CP is not listed here in this particular instance, but when you run it, you'll get that. Okay, you might not get, so run that to do the CPK and then post them again in in D2L. Sorry about that. Then there's another exercise, and in that same Excel spreadsheet, the third tab will be the pin diameter. So do the CPK for that, okay? We're not going to show you the answer for that one here. Okay, so to summarize this chapter, and it is a very short chapter, so please read it. It's good understanding there. This is just some of the ways that you can solve or list problems, and that can be solved using this process capability, okay? There's quality issues. It can reveal too many defects by operations. Maybe your product's unstable. Maybe it's drifting. You could have a wrong distribution. You could also show possibility how that it might be rooted from a bad raw material. You could have too much scrap or rework, and then you might have trouble meeting schedules. This can also show you how you might be able to develop some new products, methods, okay? Maybe a new way to make the product itself. This also shows you ways you could possibly have some cost reduction. You can have automation, machine and tool design, or maybe you need some new machines, and elimination of difficult or expensive procedures. So that's what this really helps you with. So keep this tool in mind when you're doing your products, your process, and your quality project. Okay, so continue to work on your project, and then read chapter 19 and 20. So this is at the end of the book, which does a nice summary, but we still have to cover a couple other chapters, which I wanted again to emphasize that I wanted to make sure you could all do that with your 30-day trial. Please finish any open activities because you're being graded on these. All right, so I hope you have a good night, and I'll talk to you soon. If you need anything, just text me email me. And I'm planning on doing a live Zoom next week to catch up with everyone and all the classes. So look for an invitation in there. All right, I'll talk to you soon. Have a great night.